Hello class, and welcome to today's algebra lesson, which is about quadratic functions, their key features, and transformations. By the end of today's lesson, you will be able to identify the key features of a quadratic function, as well as identify transformations to these functions. So, a quadratic function is a nonlinear function written in the form f of x, or y, equals ax squared plus bx plus c. So right now it's written in its function notation. You can also see them written as y equals ax squared plus bx plus c. This equation format right here is what we call standard form. That is how we are going to see quadratics written the majority of the time that you encounter them. The key piece of a quadratic is that you have this ax squared part. So a number times x squared. The number could be 1, could be 17, it could be negative 2.5. Whatever it is, there is an x squared value in part of the function. The shape of a quadratic function on the graph is called a parabola. It is a curved function that matches the graph of a quadratic. Its general format looks kind of like a U, which we will see in just a moment. Vertex form is the other way that we can write out quadratic functions. Again, this original part was called standard form. The other way we can write it is in vertex form, and this is a quadratic function written to show the position of its vertex. So a vertex is the highest or lowest point on the parabola. If you are looking at this example here, this parabola, again, resembling this U shape, its vertex is this point down here. It is its lowest point on the graph. When it is written in vertex form, you can pull the vertex out of the equation with the h value, comma, the k value. So it's taking that point out of the equation. It's written in a specific format to show you exactly where that highest or lowest point is. The axis of symmetry is what cuts this graph in half. Every single parabola has a vertical line that splits it in half. It's going to be written in the format x equals, and then this equals part is going to be some number. When it's written in vertex form, that's going to be x is equal to h. When it is written in this standard form, there's a slightly different procedure for finding that axis of symmetry and the vertex, which we will go over in just a moment. The final key feature of a parabola is it either opens up, so maintains that U shape like this graph does, or it can open down, where it gets flipped upside down to make an upside down U. Now, how does that upside down U occur? That occurs when our a value, or the number in front of x squared, is going to be a negative. So anytime your quadratic, this is just the simplest form of a quadratic where it's just x squared. So if it is a positive number, that means it is going to open up. This fx squared is shown by the red graph. The g of x equals negative x squared means that it opens down. So the parabola opens up when it is positive. It opens down when it is negative. So the direction going up or going down depends on the very first value in the equation. If it is positive, then it is opening up. If it is negative, then it is opening down. So we're going to start by just identifying these key features. When you do this, the first thing that you are going to look to find is always your axis of symmetry. I'm going to abbreviate that to AOS. Right now, we are written in our vertex form of the problem. So I've got x. There's nothing in that parentheses part, so that means it's x minus 0 squared, and then plus 9. So your h value, the value associated with x, is 0, meaning that your axis of symmetry is at x equals 0. So the vertical line is where the x coordinates are at 0. Your vertex, or that highest or lowest point on the graph, in this case is going to be 0, 9, your h, your k value. And then we have to decide what direction that it opens. And because this is a positive x squared, that is going to tell us that it opens up. So our graph points upward as it makes that U shape. Now, we also want to be able to do that for other examples of problems. So here's another example of a quadratic that is written in vertex form. So we're going to start by pulling out that h value, which in this case is 5. So that means your axis of symmetry is at x equals 5. So you would go 5 to the right, and that's where your graph would get split in half. Your vertex point then is your h value, 5, and then your k value, which in this case is negative 13. So we would have a point at negative 13. And then based on the fact that the very front of this problem before the parentheses has a negative, that tells you it is reflected, so it's flipped upside down. That graph is pointing downwards. Go ahead and try this one on your own. First, finding the axis of symmetry. So your axis of symmetry is x equals 7. Now go ahead and find your vertex. Your vertex for this one is going to be at a positive 7 and a negative 6 as your xy coordinate. Now go ahead and determine if the function opens up or opens down. In this case, our function is opening up because there is no negative sign in the front of the problem. We also are able to identify these key features from a function written in standard form. The procedure is just slightly different. When you are finding your axis of symmetry, there is a formula that you are going to use every single time. So to find your axis of symmetry, your formula is x is equal to the opposite of your b value over 2 times the a value. If you remember all the way in front here, we talked about standard form is ax plus by is equal to c. Or excuse me, not equal to c, but adding or subtracting c. So we have an a, b, and a c in the problem. So when I come back to identifying these features, the first thing I want to do is label my numbers as a. So negative 0.75 is a because it's in front of x squared. B is a positive 3 because it's in front of x. And then C is negative 4 because it's that last number being added or subtracted. So this is our formula for calculating our axis of symmetry. Given this particular problem then, we would say x is equal to opposite of b, so the opposite of 3 is negative 3, over 2 being multiplied with our a value of negative 0.75, which means that we've got negative 3 over negative 1.5, telling us that our axis of symmetry is going to be x equals positive 2. So negative divided by a negative is a positive. 3 divided by 1.5 is 2. Now, to find your vertex, you are going to plug in x and solve for y. So this is the second step of our problem, and this is when we are trying to find the vertex. So I'm going to take now my x value, which was 2, and plug it into the equation. So I'm going to say negative 0.75 times 2 squared plus 3 times 2 minus 4. You can plug this entire thing into your calculator, and when you do that, you are going to get a value of negative 1. This means now that your vertex is located at the x value that you calculated for the axis of symmetry, so at 2, and then your y value is negative 1. The last piece that we look at is what direction that it opens. And just like when it is written in vertex form, we come all the way back to the beginning of the equation. Since it is a negative number in the front, that tells us that it is opening down. Go ahead and calculate the axis of symmetry for this equation on your own. So our axis of symmetry is negative 4, so the opposite of our b value over 2 times our a value, and then again this last part is your c value. So your axis of symmetry was x is equal to negative 1. Now go ahead and calculate the vertex on your own. So we plug in negative 1 into the equation. We end up with a final answer of 7. So your vertex is at negative 1, positive 7. Finally, determine whether this opens up or opens down. Correct answer for this one is opens up because that 2, that a value in front, is positive. The other piece that we are going to look at is the transformation of these functions. We already talked about it being transformed from opening up to opening down. The other thing that can happen, another thing that can happen, is we can make this function wider and narrower. So again, the most basic function is represented by this red curve in here. The second curve, this green curve, you will notice is wider than the original curve. This green curve is represented by 0.5x squared. So that means when the a value, so the number in front of x squared, is between 0 and 1, your function is going to get wider. It is going to stretch out beyond where that original graph would go. On the flip side of that, if it is bigger than 1, that means it is going to be getting narrower. Now notice right now, these are all positive values. Whether or not it is positive or negative, that determines whether it's going up or down. So you never look at a negative when you are trying to determine wider or narrower. The negative tells you whether it goes up or goes down. So what that means is, for an example like this, I've got j of x is equal to negative 2x squared. The negative part is what tells me that this function would open down. That is talking to me about a reflection. The 2 now, ignoring the negative, 2 is bigger than 1. So that is telling me it is going to be getting narrower, and that is looking at the dilation part. Go ahead and determine the direction and the dilation of this function on your own. In this case, it is wider because the value is between 0 and 1, and it is opening up because it is positive. The last type of transformation that we have is translation. This relates to where on the graph your vertex is. There are 4 directions that it can move, and it depends on where that value is. So if you have x minus a number, so x minus an h value, that tells you that the function is moving right that number of units. So in this case, it is right 7 units. If you have a x plus an h value, that's telling you it is moving left that number of units. If there is nothing with your x and the number being added or subtracted is outside of that squared part, that is going to be your k value, and that is going to tell you that you are either moving down, in this case it's 7, or up, in this case once again 7. So your h values control what moves left and right. Your k values control what moves up and down. So go ahead and determine how this one moved around the graph on your own. In this case, we have an h value of x minus 8 and a k of plus 3, which means that it moves right 8 and up 3. Putting this all together into multiple transformations, the first thing we always want to check for is this negative in front. So that is going to tell us that our graph opens down. Then we have the fact that there is an 8 here. 8 is larger than 1, which is going to tell me that my graph is getting narrower. There is nothing attached to the x in the squared before the squared, so that means we're not moving left or right. And then our last piece is we've got a plus 3, so a k value of plus 3 means that the graph moved up 3 spaces. With this second example, it is a positive number, so that means that our graph opens up. We then have a number being multiplied that is between 0 and 1, meaning that our graph is getting wider. And then we have that this x minus 7 is included in the part being squared, which means that we are moving to the right 7. Go ahead and try this one on your own. So we have the opens down because of the negative. We have right 12 because the squared part is negative 12. And then we have up 15 because the value after the squared is plus 15. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.